Welcome to the Explainer. Today we're diving into a project management method that's all about preventing disaster before it happens. It's called the V model, and you could almost call it the secret weapon for some of the world's most mission-critical industries. You know the nightmare scenario, right? You pour months, maybe even years into a project, only to discover a massive, show-stopping flaw right at the finish line. It's brutal. Well, the V model was literally invented to stop that exact thing from happening. All right, so here's our game plan. We're going to look at the problem with the old way, see how the V model solves it, walk through all 9 steps with a really practical example, and then wrap it all up with our final take. So to really get why the V model is so smart, we first have to talk about what it was designed to fix. And that means looking at its predecessor, the classic waterfall model. The best way to think about waterfall is like building a house, but in a really risky way. You pour the foundation, then you build the walls, then you put on the roof. And only after all of that is done, do you go back and check if the foundation is actually level. I mean, can you imagine finding a problem that late in the game? It's not just expensive to fix, it's a catastrophe. So how do you solve a problem like that? Well, the V model's approach is actually pretty brilliant in its simplicity. It just takes that straight downhill waterfall process and bends it right into the shape of a V. And this right here is the absolute game changer. Instead of waiting until the very end to test anything, the V model forces you to test and validate at every single stage. See, it's a subtle but massive shift. You're not just asking, did we build the thing right at the finish line? You're asking, are we even building the right thing from the very beginning? You're actually planning your tests at the same time you're planning the design. So what you end up with is this V shape, right? The left side going down is all about development and design. The right side, coming back up, is all about validation and testing. And the key is every single step you take going down has a matching step waiting for you on the way back up. Okay, so what does this actually look like when you're on a project? Well, it breaks down into a really clear, logical 9-step process. Okay, this lays out the whole journey for us. On the left side, you see steps 1 to 5, that's us going down the V. We start with the big picture goals and get more and more detailed all the way down to the actual code. Then at the bottom, we pivot. Steps 6 through 9 take us back up the other side, and now we're testing. We start small with tiny pieces of code and work our way up to testing the entire system. And you see it, right? How the steps on the right perfectly mirror the steps on the left? That's the magic of the V model. All right, theory is one thing, but let's make this real. Let's say we're a team, and we've been tasked with building a brand new stock management app for a company. So we're at the very top of the V, step 1. And before anyone even thinks about writing code, we have to ask the most important question. What problem are we actually trying to solve here? What's the core business need? Okay, so for our app, let's say the company is sick of using manual spreadsheets for everything. They're making mistakes, it's costing them money, so the goal is simple. Automate the whole thing, cut down on errors, save some cash. That is the why that drives the whole project. Okay, once we've nailed down the why, we move on to the what. Specifically, what does this app have to do to solve that problem we just identified? This is where we get super specific. We'd write it all down. The app must be able to process new orders automatically. The app must update stock levels in real time the second a sale happens. There can be zero ambiguity here. Everyone has to be on the same page. Now this is where we really see the V model in action. It's the core concept. Look how everything is paired up. While the architects are figuring out the big picture general design of our stock app, guess what? The test team is already planning the system tests that will validate that design later on. And when the developers are designing the detailed guts of the order module, they're simultaneously planning how they're going to test its integration with the inventory module. See? Every single design decision has a test plan being built right alongside it. It's happening in parallel. It's brilliant. Okay, so the coding is finally done. We've reached the bottom point of the V. Now the fun really begins. We don't just move on. We start climbing up the other side. This is the validation half of the journey, and it all starts with the smallest possible pieces, the unit tests. So what's a unit? It's just the smallest testable chunk of your code. For our app, we're not testing the whole thing yet. We're just checking one little piece, like does the order module, all by itself, process an order correctly? That's it. It's like checking every single brick to make sure it's solid before you even think about building the wall. And once those are good, then we move up to integration testing, making sure the order brick talks to the inventory brick correctly. And from there, we'd go all the way up to system testing, where we finally check if the whole app does what we set out to do in the first place. So we've seen how it works, and it sounds pretty solid, right? But is it the perfect tool for every single job? Of course not. Like any methodology, it's got its pros and its cons. And here's the bottom line. Its biggest strength is also its biggest weakness. All that structure, all that early testing and documentation, it's fantastic for ensuring quality. But that same rigidity makes it really hard to adapt if the project needs to change halfway through. It's not very flexible. But you know what? That rigidity isn't always a drawback. In fact, for some industries, it's a requirement. Think about aerospace, defense, or healthcare. If you're building software for a plane's flight control system or a life-saving medical device, you absolutely cannot have surprises. You have to get it right the first time, and that's where the V model really shines. So that kind of leaves us with one last question to chew on. In a world that is obsessed with being agile and moving fast, where does a strict, rigorous model like this fit in? Well, maybe the V model is a powerful reminder that sometimes discipline is more effective than speed. The real skill, at the end of the day, isn't just knowing how to use a bunch of different tools. It's knowing exactly which tool to pick for the job at hand.